Math of Mr. Williams, example 1, using a histogram. The histogram shows winning speeds at the Daytona 500. Which interval contains the most data values? Okay, so first off, we need to know what an interval is. Intervals are these numbers. So we have 120 to 129, 130 to 139, 140 to 149, 150 to 159, 160, and so on. Okay, those are intervals. Which interval contains the most data values? Well, the interval with the tallest bar contains the most data values. So the 150 to 159 miles per hour interval contains the most data values. B, how many of the winning speeds are less than 140 miles per hour? So we see 140 miles right here. So that means anything less than it. Okay, so how many do we think are between 120 and 129? I'm going to say there's one. How many are in the category of 130 to 139? Looks like 8. So let's go ahead and add those up. We have 1 plus 8 will give us 9. There are 9 winning speeds that are less than 140 miles per hour. All right, C, how many of the winning speeds are at least 160 miles per hour? Okay, let's go ahead and erase this. All right, so we know that it has to be at least 160, so it's basically these two bars in the end here. So how many's in that first one? We have 8. And how many do we think in this one? Well, it's just above where the 4 is, it looks like, so I'm going to say 5. Let's go ahead and add those up. So we have 8 plus 5 would get me 13 winning speeds that are at least 160 miles per hour. Math with Mr. Williams, example 2, making a scatter plot. The table shows the ages of 10 adults and the numbers of gigabytes of cell phone data used by each adult in 1 month. Make a scatter plot of the data, identifying the outliers, gaps, or clusters. Okay, so here we have our table. What we have to understand is the first column is going to represent our X value, and then the second column will represent our Y value. Let's go ahead and make a set of ordered pair here. So the first one would be 37 and 3.2. Let's go ahead and graph that. All right, our next one would be 30 and 3.3. Let's go ahead and graph that one. All right, and next we have 32 and 3.1. Let's graph it. All right, next we have 65 and 9/10. Let's graph that. All right, next 53 and 1.8. Graph it. Then 25 and 3.5. Now we graph it. We have 59 and 1.3. And we graph it. We have 30 and 1.8. And 50 and 1.9. And lastly, 34 and 3.3. Okay, so we've made our order pairs. We've made our scatter plot of the data. And now we're going to identify any outliers, gaps, or clusters. So the first one I'm going to focus on is the outlier. You can see there's an outlier right about here at 30 and 1.8. And there is a cluster of data from about 25 years old to 37 years old. And a gap in the data about 37 years old to about 50 years old. Math of Mr. Williams, example 3, identifying relationships. Describe the relationship between the data and the scatter plot. All right, so we're looking here, we see we have television size and the price in dollars. Well, the points appear to lie close to a line with a positive slope. You can see that because it's going this direction. So basically, as the x is increasing, the y is also increasing. So the scatter plot shows a positive linear relationship. Math, Mr. Williams. Example 4, finding a line of fit. The table shows the number of absences in the school year and the final exam scores for several students. Make a scatter plot of the data and draw a line of fit. Okay, let's start with that one. So I understand that this is still X and Y as far as motor pairs. So what I'm going to do is I'm going to understand that each one of these is an ordered pair. I'm going to go ahead and graph them. So I'm going to start off with 097, then 388, 293, 583, 773, 970, 588, 194, 965, 873. All right, so now we have our scatter plot, and now we're going to draw a line of fit. So basically a line of fit, we're just going to try to hit as many dots as possible with about the same number on top and below the line. Okay, and now we're going to go ahead and find an equation. So what we need to find first is the slope. So we know slope is the rise over run. So in the case, let's go ahead and find two dots we can use to find the rise over run. Okay, so let's go ahead and use 194, and we'll say our last one down here, this 970. So we had 194 and 9 and 70. All right, so we're going to talking about the rise over run. So what we can do here is do the change in y. So we'll do y2 minus y1 over x2 minus x1. All right, so that is 70 minus 94 over 9 minus 1. So that gives me a negative 24 over 8, which ends up giving me a negative 3 for my slope. So far, my equation would be y equals mx plus b, where the m, the slope, is going to be a negative 3. Then we bring in our x plus, now we got to find our y-intercept, and we can see that it was back up here in our table, y and 97, so it'd be plus a 97. So my equation would be y equals negative 3x plus 97. So C, interpret the slope and the y-intercept of the line of fit. So the slope is negative 3 and the y-intercept is 97. So a student with 0 absences is expected to earn a 97 on the exam, and the score decreases by about 3 points per absence.